Thank you, Eric, and thank you to the Académie de l'Air et de l'Espace for organizing this event and inviting me. And you could see a lot of very interesting use cases of deployment of artificial intelligence already in the previous presentations all over the morning and the beginning of the afternoon. And the key question I'm really working on with my team, we have a whole program at EASA dealing with AI. Why a program you will see through the domain reach out. We really have to see how to certify and approve AI in very various domains. And the big question is about how to use and how to certify and approve AI in safety-related applications. So that's all what you will see in this set of slides that I prepared for you today. No, the other direction. Yes. Yeah, of course, the conference is about applications. Everything is getting very concrete. Of course, there is still research and innovation linked to AI, but we have a wide range of use cases already available and for some in certification projects. I have just taken a span to show the wideness of the spectrum, let's say, of domains that are impacted by the deployment of AI. AI being as hammered, but very importantly, it's an enabler. It's not a hand in itself. It is the enabler for specific type of operations and actually growing levels of automation. On the airworthiness and AirOps side, you can see visual traffic detection as a flagship. You will see actually more from that in the presentation from Hugo, from Daidalin. On the maintenance side, we see a lot of applications coming. The visual inspection support is also a very representative case of usage of computer vision. But we have also use of large language models, ChatGPT-like, in troubleshooting procedure support, for instance. Flight training is a key element as well for the assessment of training performance of pilots. On the ATM side, ATM ANS, I always take conflict detection and resolution as a flagship as well, because it shows actually the span of automation we could have from support to ADCO to why not at some point a very automated type of operations with virtual co-controllers, why not? Aerodromes. One of the cases we can see is the detection of foreign object debris on runways. And very importantly also from the innovative air mobility side, drones led today at least, and the use space management, we see a lot of support of AI foreseen at least by the industry and applicants. What are the underlying technology? Also here, a wide span. First, computer vision is all over the place, as was explained this morning. It is one of the key elements with deep learning that was, or the key type of application that was enabled by deep learning. But we see also a lot of optimization, let's say a type of algorithms bringing their way into ATM and use space management, as well as on ATM side because of the, let's say, the culture of using radio and natural language. Natural language processing has also quite a weight in the applications we see from applicants. But very importantly, and you will see that in the next slide, we've sliced the problem in pieces. We started level 1, 2, and 3. I will explain a bit more about that. And for this level 3, which is the more advanced automation, actually in the direction of what was presented by Baptiste just before, we need actually a reasoning element that comes more and more into the game. We will talk, or you talked with Juliette this morning about hybrid AI. I will present also a bit of elements on the technical scope of the roadmap that needed to be augmented in 2023 to specifically tackle this type of elements. So from the nature of the large wide spectrum of domains and of technology and techniques, of course, we tried here to answer the question that was raised in the previous panel, to centralize initially, to see how generic the problem can be. And actually, this logic of trust that we can put in the AI application is the central element. That's why the roadmap was built around this AI trustworthiness concept, giving a shape actually to the framework, to elicitate what are the requirements we will put on safety-related applications. We went from the start, the first roadmap was from 2020, February 2020. We started with 3 phases, which we follow actually and timely so far. The first phase was exploration. And as I said, we sliced the problem in three subsequent elements. There is a bit more subdivision after, but level one is about pure assistance to humans, systems that are assisting, augmenting human end users, whoever they are, pilots, ATCOs, maintenance officers, etc. And from that perspective, no decision making made by the machine. That's where we moved progressively to a level 2, human-machine teaming. That's a key concept as well, more ensuring the nature, let's say, of the interface and the capability of the machines in terms of decision making. The first level was focused more on the capacity to assure the intended function of the machine. The second level brings us to the human factors for AI dimension, which is another building block of the roadmap. And the exploration will carry on. We entered this year in 2024 in a consolidation phase, the phase 2 of the roadmap, which will involve actually rulemaking activities already on the level 1 and 2. Because we have a concept paper available and already as a reference point for serving as reference through special conditions for the first certification projects. So it has matured over time and is really usable already. So we need to turn it now into a set of requirements and acceptable means of compliance. You will see a bit more about that of the presentation. And at the same time, in parallel, we carry on the exploration on what we call the level 3, which is, again, more advanced automation, meaning where the human end user is either a remote operator not involved completely in the loop of operation, at least until alerted to do so, or even the case of level 3, where we don't have a human in the loop of operation, which, of course, is another step of complexity, which we need to manage from a safety perspective. All of what we've done so far was totally oriented by the prognostic of industry and all our stakeholders, meaning in 2019, the effort of creating a roadmap was triggered by first applications coming in. First, also innovation partnership contracts. We started with 2 IPCs with Daedalin, creating and giving shape to the W-shaped process for the learning assurance part. And then we progressed and continued the exploration with Rockwell Collins, with Boeing, through other innovation partnership, but also with research, teaming up with Airbus and other startups to get, actually, to give flesh to those requirements that are the foundation for the AI trustworthiness framework. Another phase of pushing barriers will come later. And very important to say is any of the examples I showed actually is not about autonomy itself. It's about more advanced automation. We put with the definitions in the roadmap the word autonomy far away, so 2050 and plus. So it's kind of compatible with the roadmap, I think, from Baptiste. But just to say that we are not striving for autonomy. Autonomy for us is something where machines would take and set their own goals or usage domain. That's not what we are considering safe and certifiable today in aviation. But between that end of the game, which is probably very suitable for other type of application, non-safety related, and where we are today, there is a long range, as you can see, of approvals that will come starting 2025 with level 1. We already have very advanced level 1 certification projects, and getting progressively up to 2035 with a crystal ball today towards the high end of what we call human AI teaming, level 2B, and the first more advanced automation, 3A, 3B type of applications. Based on that, and very rapidly on the scope of technology, it's always good to have a picture of what we call AI and what matters from a roadmap and a requirements and guidance perspective. We started with a reduced scope. Machine learning, deep learning was the trigger in 2018. That's what we started with. I'm not repeating exactly what is machine learning, what is symbolic, etc., because David and Juliette made a very good job at explaining all of that. And then we saw in 2023 the need to expand the scope to more logic and knowledge base, so symbolic AI and pure statistical approach, but mostly also accounting for this notion of hybrid AI that was well developed this morning. And the message being always, we keep a safe subset of this technology. The point is not to develop and get the last hype of AI into aviation. The point is to see what it can serve as a purpose and ensuring safety, putting the right boundaries. One boundary is definitely the level of safety, level of criticality we can accept. Today, we've set the scene at a major failure contribution. That's a first barrier, let's say, that we see as at least a testing barrier that seems to be feasible for at least level 1. Let's see how we can go further. But also, limiting the notion of advanced or continuous learning to an offline learning logic. So freezing models at the time of certification is an absolute key requirement we still have for safety-related applications. Yes, great, thanks. This scope of technology, again, we are not trying to define AI. We took the one that was the initial definition in the AI Act, the EU AI Act draft from 2021. We didn't update based on the published AI Act, but we might do so. The point is that AI is more in the roadmap of EASA, an identification of the subset of technology that requires additional requirements. We are not trying to reinvent the wheel for, I don't know, autopilots in cockpits. Everything was absolutely certified per the book, and we know why. Here we are really dealing with what goes over the fence that is called AI, that can be called AI, whether perception or decision-making support. It doesn't matter. The point is the technology also orients the requirements development. We went some way, let's say, in the 5 past years, again, triggered by innovation and research projects, but also by concrete projects, creating this concept paper and updating it over time, consulting also, even if it's not a rulemaking artifact, we really want to consult it to allow actually a further maturation, which proved to be very effective in the sense that we received 900 comments in 2023 on this second proposed issue of the concept paper. And we took nearly a year to mature and address all the comments to release the final published version of this issue 2 on the 6th of March 2024, so this year. And everything we publish, you can find on the EASA website under the address that you see here, /EASA/AI. Based on that, what is in the concept paper, and in a nutshell, this is a slide I prepared for the EASA AI Days to give a top-level view. It's all organized around 4 building blocks, but instead of going to the building blocks, let me give the sub-blocks that were relevant for the different levels, and each level bringing a higher level of, let's say, of needs and requirements. The other ones, the other building blocks feeding actually any of these levels. So the level 1 was really focused, as I said, on the assurance on the system itself, on the system or the tool. I'm talking system, but because we have embedded systems, of course, but we have the notion of tools used under approved organizations, which we saw in some of the use cases as well. Everything applies to both. And the learning assurance, the famous W-shaped process, I will not enter in details on that, but that's the shape we gave to taking into account the specificity of machine learning with data management, learning management before, and first step of verification that creates this W shape before entering in the traditional shaped implementation process and the subsequent verification. We elicited also requirements on the AI explainability, the understanding of the outputs tailored to the type of stakeholder. We have, of course, development explainability and operational explainability, focused more on the operational usage. That's 2 different types. Then we have the continuous safety and security risk assessment. That's a concept building on continuing airworthiness logic, but bringing it a bit further based on the nature of the data-driven approaches we see coming here with those use cases. At level 2, for the human AI teaming, definitely specific guidance on human factors side for collaboration, collaboration to subsequent levels. We'll not enter in details on that, but you can see really all the details in the concept paper issue 2. And the ethics-based assessment was made a bit invisible for level 1, but starts really to matter for this notion of more interaction, advanced interaction between humans and AI-based systems. This is the scope of the rulemaking task that you will see on the next slide. And in parallel, as I said, we still carry on with the exploration at level 3. Concept paper issue 3 is now starting to be prepared. We already anticipated with our scientific committee the design principles for level 3, meaning more advanced automation. We will feed it in, but we will also take the chance of this concept paper issue 3 to extend the scope to other techniques like reinforcement learning, which was left a bit of a leftover from the first 2 issues. Symbolic, statistical, and hybrid AI, no surprise. Perfect. Thank you. The rulemaking plan explains really where we are going. So we published the terms of reference for rulemaking task 742 that was already anticipated for 2 years in our EPAS, in the plan for aviation safety at European level. It's driven, of course, by the existing and published AI Act, which entered into force in August this year. Yet for aviation, we have a grace period of 3 years. So in 2027, we shall be ready. That's why also the time frame for the rulemaking to go from now to from Q2 2024 to Q4 2027. And based on that, we see in fact 2 steps, which you can see here graphically on the diagram. Of course, the basic regulation is at the same level like the AI Act because it's also an EU regulation. We put it just 1 step below because the AI Act is also and is foremostly an horizontal regulation, meaning impacting also other sectors. So to show a complete view, we put it at the top. 1 article of the AI Act, the Article 108, is giving a mandate, in fact, to EASA to update the EASA basic regulation to take into account the requirements for high-risk systems, AI-based high-risk systems, considering what they call Chapter 3, Section 2. It is simply the area of the AI Act that is dealing with the requirements to high-risk systems. We will reply to this formally through a Part AI, which will also at the same time gather the generic requirements to organizations and authorities managing or approving AI. And in a step 2, sorry, I'm forgetting the very important point, which is where the concept paper actually will land. It's in the AMC GM, so in the acceptable means of compliance guidance material, as much as possible, as usual, based on current standards development, in particular the WG 114 G34, but also looking at the Sensenelec and in a wider sense at what is happening at international level in the ISO IEC standards development working groups, in order to ensure a consistency, clearly not an harmonization, but a consistency. While we look more at Euroca SAE, we are very engaged in this group, of course, and very happy of the level of, let's say, synchronization we could do between the concept paper and the current standard development. But it's also to keep this aviation framework entire and intact. We have a long history of development assurance for systems, safety assessment, cybersecurity for systems. Of course, everything we produce on the AI side has to be embedded and integrated in the existing, therefore keeping consistency with existing standards, whether system or software or hardware level. The step 2 is probably the most complex and the puzzle part, which is creating the link, actually, this generic framework that you see in the middle to the different domain-specific regulations, their AMCs, GM, and of course, the certification specifications if we think initial airworthiness. But as you understood from the start of my presentation, we are not thinking domain-specific when we do the generic parts. Therefore, we pushed really away all specificities, taking them still in the back of our mind to create something meaningful, but really taking the chance of this rulemaking task to investigate domain by domain what is missing, what is extremely compatible with what is already there, and what needs to be augmented or either generically or specifically. So that gives you a good understanding of where we are in terms of let's say, of roadmap and consolidation phase. The very important message I always keep at the end of presentations is this collaborative approach. You really felt it also through the presentation so far in the conference. It's extremely important for us, EASA. We are not an AI company. We are an aviation safety agency. We need actually to understand from use cases from startups, from global players, but also from the research, what is at stake, what is feasible, what is not, what is safe, what is not. And this is what we did by teaming up a lot on the way, as I mentioned rapidly, on innovation partnership contracts with several companies. Memorandum of understanding are ongoing, but also the first applications and certifications. We keep very aligned to the working group effort, as I mentioned on the previous slide, and we also use research as much as practicable, groups of research, and we are very connected also to ANITI and DEAL, but at European level, leveraging actually the Horizon Europe framework, either CESAR projects or Clean Aviation for some, or actually tailor-made projects like the MLEAP project, which was really, for me, a success because it brought us actually to a 500-page report explaining, stating what are the practicable means of compliance for certain of the complex topics on the learning assurance side. And we will try to start a similar project for the machine learning and human AI teaming aspect in the future. That's all what I brought to you. I think perfect on time, hopefully. Thanks for your attention, and glad to take questions just after. Thanks.